fundamental concepts in statistical inference are statistical hypothesis testing and population parameter estimation. Statistical hypothesis testing is the use of statistical methods to test a hypothesis. Population parameter estimation, the analytical method for calculating the expected population parameter based on a sample statistic. This chapter will deal specifically with the process behind hypothesis testing. A scientific method is a process by which we investigate phenomena, whether natural or social in nature. That image I have below is a graphical version of a scientific method for you. So we start with a theory of why the phenomena is occurring or acting such a way. So for hypothesis, theory helps us create predictions about what we expect will happen within our sample. For our observations, in order to test the theory, we need to observe what is happening in a sample of the population. This might involve collecting data using a survey instrument, an experiment, or other type of data collection method. Generalizations. Once we have the data, we can test our hypotheses using statistical analysis. We will touch base on null hypothesis and alternative hypothesis in the next couple of slides, as well as one and two-tailed tests. Statistically significant is when it's unlikely that it occurred by chance. Significance level value is used to determine whether to reject or fail to reject the null hypothesis. A critical value is the corresponding value to the significance level that determines the boundary for rejecting or failing to reject the null hypothesis. A test statistic is a summary value based on our sample data that indicates how far our sample estimate, such as the mean, differs from zero under the null hypothesis distribution. A null hypothesis states that the result was due to chance from sampling error, and as such is not a true difference. An alternative hypothesis is what every researcher wants to get, so the exact opposite of null hypothesis. When a hypothesis states a specific direction, such as high or low, etc., we refer to this as one-tailed hypothesis.
Pause this review and check out the examples.
When a hypothesis does not have a specific direction of difference, relationship, or effect, we refer to this as a two-tailed hypothesis.
Pause this review and check out the examples.
Pause the screen and have a read. These questions will be answered in the next couple of slides. A significance level is the value used to determine whether to reject or fail to reject the null hypothesis. It is the portion of area under the sampling distribution curve that represents the probability of observing a score either above or below the point. The confidence level tells you how sure you can be. It is expressed as a percentage and represents how often the true percentage of the population who would pick an answer lies within the confidence interval. The 95% confidence level means you can be 95% certain. The 99% confidence level means you can be 99% certain. Most researchers use a 95% confidence level. The critical value differs by the type of statistical analysis you are doing and whether the hypothesis is one-tailed or two-tailed. Also, the corresponding value to the significance level that determines the boundary for rejecting or failing to reject the null hypothesis.
Pause this slide and read and pause the next slide as well.
So now we're going to discuss the 5 steps of hypothesis testing.
Step 1. State the null hypothesis and research hypothesis.
Step 2, define the sampling distributions and the critical value. Step 3, as shown right here. Step 4, please keep reading. Step 5, the easy part, interpret the results.
Type 1 error is probability that you will reject the null hypothesis when it was actually true. Type 2 error occurs when we fail to reject a false null hypothesis.